Good morning. Welcome to the last day of class for us. Crazy. Absolutely crazy. Good morning, Joey. If you think about everything you've learned this semester, you should be very proud of yourself. You guys have done a good job. Morning, JC. How goes it, everybody? It's Wednesday, pretty gloomy outside. Hello, JR. It is the last day. I told my husband, I was like, it's my last day of streaming Twitch. He goes, oh, that's so sad. But it's been good. It's been good. I like this platform for teaching online. I really do. Don't forget to fill out your guys' evaluation. I mean, honestly, let's be honest. You guys all filled it out. Everybody who's here right now. You filled it out. Let's see. Let me look where Section G is at. So Section G is at a 58% response rate. So if you know anybody else in this section... That's funny. I don't even know what I would stream about. Like... I don't know, maybe, I don't even know. I don't even know what I would stream about. Find random problems. So 35 out of 60 students for this section have responded for the course evaluations. So we're almost there. Not linear algebra. What's wrong with linear algebra? Linear algebra's fine. It's not... We don't teach it the way that a traditional math linear algebra course would be taught, which, I don't know, personally, I prefer the way we teach it because it's much more practical. But, I don't know. Doing problems is fine. I did the practice problems this morning. I did them all this morning, and I checked all of my work. I was very proud of myself. I shouldn't say. Let me not say that. I wasn't proud of myself. I know how to do the problems, but I was happy that the practice problems took me about an hour-ish to do and check and fix. I found an error in one of the solutions, which gives me confidence that you guys will be you'll be fine on the final. You can do it. You can do it. Yeah. B.I. Duncan. I don't even know how to separate that username. Yes, so student evaluations for Section G are at 58%. So you've got to get about 10 more students. 10 more students to respond. But you're doing better than Section H. Section H is only at 55%. Anyway. I'll post it on Discord later. I don't know what the other sections are doing, but I'm always under the assumption that you guys are winning because you're my students, and my students are always better than other instructors' students. I don't know why, but that's always my underlying assumption, is that my students are always better. So, I mean, MATLAB, I just want to comment on this. So most of you guys are MAE students. There's a variety of other students as well. You will see MATLAB later on in your courses. Some of you guys will see it in sophomore year. Some of you guys will see it junior year. But just make sure you're using MATLAB. Even if it's like to check your solutions. So if you're taking statics next semester, use it to check your solutions. Just somehow just keep practicing it in any way, shape, or form you can. because MATLAB's really important for you guys to practice. It'll be important for you guys to know. The nice thing is you can always come back to these videos if you want, which is one of the benefits of being online. Not every semester has videos to go back on. Okay, so welcome to the last day of classes for us. You still have 2 more days for everybody else, but last day of classes for me. Today, I am going to go through the practice problems. I hopefully will be able to get through all of them. If not, I will make a video. Don't worry, you'll have all solutions. Hopefully you practice them in some way, shape, or form. Or looked at them. If not, that's completely fine. You'll practice with them later on. But I'm going to go through and talk through the thought process for these problems. I'm going to show you guys how to set them up and essentially recommendations for how to approach problems like this. So let's go ahead and start. Okay, problem 1. Okay, before I forget, there is, under the final exam folder, you will now be able to see my recommendations for beginning the final exam when you show up on the final exam day. It's going to be proctored just like the midterm, so make sure you have your phone or whatever camera you have angled behind you to see your screen and your workspace. Log into UBbox, log into UB Learns, log into UB Zoom. All of those fun things. Make sure you have pieces of paper. There are 6 problems, so you want 6 pieces of paper because you'll use 1 per problem just for organization. That really helps. Write your name at the top of each piece of paper. And this is all you can do. You can all do this before you we start the exam. The exam, you will have 2 hours to do everything. So 2 hours to do the problems and scan and submit them. So make sure you know how much time it takes you to scan. I understand a lot of you guys scan with your phones. That's fine. Just grab your phone from where it is, scan, leave the camera on. I don't care. But scan it in and then you can submit it. So make sure you're aware of how much time it takes you to scan because you'll need to allocate that in your time frame. Okay. So, exam is released. It's going to be on UB Learns, links to UBbox, so make sure you open those links in separate tabs. Do it all at once, just for time's sake. The questions will be true-false again. Just mark them as true or false. I don't care. That doesn't matter. Okay, so you get to your exam, the exam is released, you open up problem 1, you have your sheet of paper, and you have your name at the top, and you're starting to solve. So nicely label things, and you read the problem. There's a typo here. So it says, consider 3 vectors in R4. R4 is the space they live in, which means that, yes, Holly, I got your email. Oh, that's what I wanted to say. So also on UB Learns, under exam information, you will see the Zoom link. And the Zoom link will tell you whether or not you're taking, it'll just say Zoom link for normal exam. It'll say Zoom link extended time if you have extended accommodations. And then it'll say Zoom link makeup if you're taking the makeup. I will send that out in an email. But you can check under there to identify that you're taking the right exam. Which for most of you guys, it's not a problem. You're just taking the normal exam. But for some of you guys, it might make a difference. Because if you don't, those who are taking the makeup are expected to show up at the makeup. Those who are taking the normal exam are expected to show up at the normal exam. So make sure you're going to the right one. Okay, so now let's do the problems. Sorry about that. So it says, consider 3 vectors in R4. R4 means they just contain 4 numbers. They are in a 4-dimensional space. They have X, Y, Z, and another axes that we can't physically draw because we live in 3D. These vectors are placed in the rows of a matrix, so it doesn't really matter what that looks like. We don't know what vectors these are. We just know they're placed in the rows of a matrix. So it looks like this. Come on, pen. There we go. Which is thus 3 by 4, given the rank of 2, so the rank of this matrix would be equal to 2. Answer the following questions. So A, Is the set of vectors linearly dependent or independent? So when we're talking about set, we're talking about all three together. So if the rank is 2, that means this set has 2 linearly independent vectors. However, we don't talk about the individual vectors, we're talking about the entire set together. So the entire set is going to be linearly dependent. And then the justification is because rank of A is less than the number of vectors. So since the rank of A is less than the number of vectors, therefore they are linearly dependent. If the rank of A was 3, then it would be linearly independent because all 3 of them are linearly independent. But since the rank is 2, all 3 of them are linearly dependent. B, what is the span spaced by the vectors? So the span is a blank D space in R blank. This first D, this first blank, not this first D, this first blank is the number of linearly independent vectors, which is equal to the rank. So it's going to be a 2D space in R4. This blank is the number of numbers in each vector. So they live in R4. There's 4 numbers, therefore it's a 2D space in R4. It's a plane in R4. C, true or false? None of these vectors can be written as a linear combination of the other 3. That is false. These 3 vectors, they're linearly dependent. Therefore, I could technically write them as something like this. 2x1 plus x2 equals x3. Given that these are vectors, x1, x2, x3 vectors. This is what it means to be linearly dependent. I can write it as a linear combination. C1, x1 plus C2, x2 equals x3. Or U, V, W. So this would be false. These vectors can be written as linear combinations of the others. Okay, D. Given U, V, and W, determine the values of A, B, and C such that W equals U plus KV. So notice if I look at these vectors, I have these unknowns. A lot of your questions on your exam, just like the practice problems, are going to have those unknowns in there. They're going to have letters and not just numbers. That doesn't matter. Keep solving everything the way you would normally, as if it was all numbers. So if I want to determine values of A, B, and C such that W equals U plus K plus V, where K is a constant, what you do is just set it up. What do you mean, JR? And C is any rational number, like the big letter C or this C? Which C? Yes, C1 and C2 would be any rational number. Okay, so for part D, I'm literally just setting this up, starting somewhere, setting it up. I'm hoping that I'll have enough information to solve for A, B, C, and K in this instance. So I've got U plus KV equals W. And then I'm just going to solve for everything. So this one tells me that 0 plus K times negative 2 equals negative 2, or K equals 1. Yay! One unknown solved for. That was easy. So then I have A plus 3K equals negative 2. If K is 1, I have A plus 3 equals negative 2, or A equals negative 5. There's my second unknown. So you'll notice as you go through these problems, if you have some unknown variable, some unknown number, that's just a letter, A, B, C, you should be able to solve for it eventually. Then we have negative 1 plus BK equals negative 2. If K is 1, I have negative 1 plus B equals negative 2, or B equals negative 1. And then this last one, negative 2 plus 0, K equals C, or C equals negative 2. There we go. I solved for A, B, C, and K. You didn't have to solve for K, but I boxed it anyway. And then E. Determine values of A, B, and C such that the three vectors are orthogonal. Can you only solve the rank number? No. Excavation Raven. Welcome. Can you only solve the rank number for a square matrix? No. Nope. You can solve for the rank for any size matrix. Any size matrix. You could solve for the rank if you have a bunch of two-dimensional vectors. So if you had 2 columns and 5 rows, you could technically solve for the rank. Your goal is to essentially to find as many zeros in your lower triangle as possible. It just so happens, if you end up with something like this, you're probably going to end up with a lot more 0 rows. So here you might end up with 3 0 rows. Here, you're still trying to get that lower triangle of zeros. So if you have more columns than rows, you aim for your lower triangle of zeros. If you have more rows than you have columns, you're gonna most likely end up with a lot more rows that are zeros. Your goal is to just find as many zeros as you can in that lower triangle. You don't care about the upper triangle, just the lower one. Okay, E. Determine different values of A, B, and C such that the three vectors are orthogonal. So I have U, V, and W still. When it says that the three vectors are orthogonal, you immediately should jump to the dot product equals 0. So if all 3 are orthogonal, that means I'm talking about U dot V equals 0, V dot W equals 0, and U dot W equals 0. So I'm going to take the dot product between all of these, and it should give me a bunch of equations that I can use to solve for A, B, and C. I'm going to zoom out a little bit so I can see everything. So U dot V looks like this. 0 plus 3A minus B plus 0, and then I'm going to set that equal to 0. V dot W looks like this. I'll just use my solutions. V dot W looks like this. 4 minus 6 minus 2B plus 0 equals 0. That's nice. It only has B in there. And then U dot W equals 0 minus 2A plus 2, come on, pen, minus 2C equals 0. So here's U dot V, here's V dot W, and here's U dot W. So if they're all 3, if all 3 are orthogonal, then all 3 dot products need to be set to 0. So using this one, I can see that B ends up being -1. If I plug that in to this one, -1, then A ends up being -1/3. For time, I am not showing all of my work. You should at least plug things in and show that you're plugging in these values in the right spots. So if I plug in -1/3 for A, it ends up with C equal to 4/3. There we go. There's problem 1. Woohoo! If I wanted to check problem 1 with MATLAB, it would look like this. It would look something like this, where I can literally just say A equals B equals C equals K equals, enter in what I got for one of the problems. So I had K equals 1, A was equal to -5, B was equal to -1, and C was equal to -2. If I plug those in and solve for, and just show that for part D, that W equals U plus KV, I can over and just look at my answers. So here it matches what I got for W. Same thing for the second part. If I got A to be -1/3, B to be -1, C to be 4/3, and I plugged all of that in, did a dot product between them, I should get 0, 0, and it's not quite 0. It's practically 0. This is what it looks like using format rat. which is just a really small number, and then it's just due to rounding error. So anytime MATLAB gives you like an asterisk or something like this, it's practically 0. It just so happens that whenever you have 1/3 is like a really annoying number to the computer for some odd reason. And it can't calculate it exactly because it goes on forever repeating. So this is where you might have some rounding error, but it's 0. It's practically 0. Just as a strategy, I encourage you to solve all of the problems first and then go back and check them in MATLAB if you have time. That's what I did this morning. I solved all my problems and I was like, okay, let's go back, solve them in MATLAB, or check my answers in MATLAB. Notice with MATLAB, when I plugged things in, I just plugged in my answers to check to see if they were correct. I didn't try to do anything fancy to have MATLAB solve it for me. I just plugged in my answers and checked to see, yep, that makes sense. Plugged in my answers, checked to see if the dot product was equal to them all. Okay. So just plug in your answers, check it, move on. I actually did find an error, I think here. I think I got C wrong when I first calculated this. Anyway, okay. Okay, so that's problem 1. Problem 2. Problem 2 is where I found the error in the solution. Okay, so problem 2, it says consider a 5x5 matrix. You will not see a 5x5 matrix on the exam. The biggest will be a 4x4, but this is practice. So if you can do it with a 5x5, you should be able to do it with a 4x4. Or a 3x3. A 2x2 is a little too small. So 3x3 or a 4x4. Okay, so here it says determine a value of A. So once again, we have that unknown in my matrix, which is fine. Don't worry about it. Just keep moving forward. Determine a value of A such that the determinant of A inverse equals 1/8. If the determinant of A inverse equals 1/8, that means the determinant of A should equal 8. Because if you look at your determinant properties, the determinant of A inverse is just 1 over the determinant of A. So I need to find a value of A such that the determinant of A equals 8. Oh, look, hey, there's my answer to B. Woohoo! And it turns out you don't even need to know the answer to A in order to solve C and D. So here's my answer to B. For C, if I already know the determinant of A, then the determinant of 2A is going to end up being 2 to the 5th times A. Because if I multiply this row by 2, 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 I need to multiply my determinant by 2, 2, 2, 2, 2. So 5 times. So 2 to the 5th is, determinant A. 2 to the 5th is 32. 32 times 8 is 256. And then same thing for D. Determinant of 2, A to the inverse ends up being the determinant of 2A times the determinant of A inverse, which I already have both of those. So it's 256 times 1/8 or 32. So even without doing A, I can already solve for B, C, and D. And then I'll go back and do A. Okay, now I'll do A. So all of those are determinant properties. Make sure you know those. Fun things. They can be useful. So I want to find a value for A such that my determinant is equal to 8. And then it says to easily solve this problem, you should reduce the matrix to REF. So that's one way to do it. It recommends doing that, which means we should probably do it. And I'll do it for review. It says record the operations you perform and use the determinant properties to find A. Okay, so if I look at this matrix, I want to get it into REF. I want my lower triangle of zeros, which means I want this to be 0, this, this, and this. All those to be zeros, which a lot of them are already 0, which is great. That means I have less work to do. So the first thing I'm going to do, which really I only need to do 4 row operations. So the first thing I'm going to do is I'm going to swap rows 1 and row 2. Because I want this 1 to be in my second row, not in my first row. and this 0 to be in my second row, not in my first row. So after I do that, I end up with this. The most annoying thing about problems like this is having to write the matrix over and over and over and over and over and over and over again. But you need to do it. So make sure you do. Yes, Aurora. The 5 is raised to the 2 is raised to the 5 because there are 5 rows. So a 2 for every row. Okay, then I want to make these a 0 and this a 0, which I'm hoping that's the last thing I'll have to do. Turns out it's not, which is annoying, but we'll get there. So I'm gonna say row 3 equals row 3 minus row 1. And then row 5 equals row 5 minus 2 times row 1. Or plus 2 times row 1. So for this one, it's going to be 2 minus 2, 0 minus 0, negative 2 minus negative 1, 0 minus 0, 0 minus 1. For this one, it's going to be negative 4 plus 4, 0 plus 0, 0 minus 2, 0 plus 0, and then 2 plus 2. So when I do that, once again, I need to rewrite this whole matrix. I end up with 0, 0, negative 1, 0, negative 1, 0, 0, negative 2, 0, and 4. This negative 2. Yes, good point. Keep track. So our determinant should be 8. Our final determinant should be 8 of our original A matrix. So I need to keep track of how my row operations are affecting this. So if I swap rows here, that means my determinant isn't 8 anymore. The determinant of this matrix is going to be negative 8 because I changed the sign. For this one, I used row operation 3, and this one I used row operation 3. So the determinant here is still going to be negative 8 because row operation 3 does not change the sign. So then my last row operation, I need to make this one a 0. So I'm going to say row 5 equals row 5 minus 2 row 3. When I do that, I'm going to get 0 minus 0, 0 minus 0, negative 2 minus 1 times negative 2, 0 minus 0, and then 4. I missed a row. I totally missed a row. Hold on. There we go. And then 4 minus 1 times negative 2. So when I do that, I get my final matrix to look like this. There we go. Okay, so originally my determinant should be positive 8. So if I change A and I swap the rows, it's going to be negative 8. If I change A and do row operation 3, it's still going to be negative 8. And if I change the rows and do operation 3 again, it's going to still be negative 8. So the determinant of this matrix should be negative 8. If my original determinant is a positive 8, then this one is going to be negative 8 because I've worked my way through my row operations. Row operation, swapping rows, you change the sign on the determinant. If you multiply a row by a constant, you multiply the determinant by that constant. And if you do row operation 3, your elimination operation, it doesn't affect it. Okay, so note this is a triangle matrix. I have my triangle, which is awesome. So that means I just multiply all of my elements along the diagonal to get my determinant. So negative 8 should be equal to 2 times 1 times negative 1 times A times 6. Or negative 8 should be equal to 12A. I'm missing minus 12A. which means A equals 8 over 12, which is 2/3. There we go. There's problem 2. Notice we did B, C, and D right away. We didn't need to do A in order to figure out B, C, and D. And then we went back and did A. You don't have to do that, but that was my choice. So I just showed that. Just make sure everything's labeled clearly. If you want to check your answers in MATLAB, once again, don't even worry about trying to get MATLAB to solve it for you. Just check your answers. So if A is 2/3, I can plug in my A matrix. I can check to make sure my determinant of A is 8. Check to make sure the determinant of my inverse is 1/8. Check to make sure the determinant of 2A is 256. And the determinant of 2 times A times the inverse of A is 32. And there we go. Determinant is 8. Inverse is 1/8, 2A is 256, and then, so JC, so what we did is, so the determinant of this matrix is -8, but this matrix is not A. This is A in its REF form. So it's the REF form of A. So if we worked our way back through the row operations, we can figure out what the determinant of A should be. So this one's -8. In order to go from this to this, we did row operation 3, which means it doesn't change. So it's still -8 here, right here, pointing at my laptop. If we went from this matrix to this matrix, we only did row operation 3 here, which means the determinant of this one is going to be -8. If we went from this one to our original A, we swapped the rows, which means the determinant changes, or the sign changes. So if this one is -8, that means the determinant of A should be +8, which is what we expect. So you have to work your way through the row operations. You have to identify how your row operations affect the determinant of A. So that's working backwards. We already know the determinant of A should be 8, so we can work our way forwards. Where if I swap rows, then it's going to be -8. If I do row operation 3, it doesn't change. Row operation 3 doesn't change. So Excavation Raven, it's open book, open note, and then MATLAB. I mean, really, that's all you should need. And that's really all you should look at. So if you're looking at your computer, you should be looking at your notes, looking at MATLAB, looking at UB Learns, looking at your test. If you're doing much more than that, then you didn't study hard enough, and you should be concerned. For time and writing everything down. But yeah, that's all you should need. Okay, so that's problem 2. And we are 30 minutes into class. Obviously, when you're doing the exam, you are not talking through it the way that I am talking through it, so it should not take you as long to do problems, unless you really don't know where to start. If you don't know where to start for a problem like this, just think, okay, so what do I know? If I'm given this information, what can my determinant properties tell me about other pieces? So you can pull open your determinant properties and you can say, okay, so if the determinant of A inverse is 1/8, the determinant of A should be this, and you can write down something that you know. Okay, so here we get to solve systems of equations, which is something we've been doing for a really long time. Okay, so given the following system of equations, write the system in AX equals B. That's pretty easy. We've been doing that for a while. So I end up with A11. Note you have that unknown in there. Do not be concerned about it. Don't say, oh gosh, I don't know how to do this. Just keep writing. Assume it's a number in your head. Like, don't think about it as like an unknown. Think, okay, that's just something. It's just another number in my matrix. So A11, 5, -2, 1, -2, 1, 4, 3, -1. That's A. X is full of my unknowns. And B is full of my values on my right-hand side. -5, 3, -2. So we have AX equals B. Then we have find the values of the cofactors C11, C12, C13. So C11, that's for the row 1, column 1 location. So it's for this location. If I want to find the cofactor, I remove the row and the column it's in. Find my remaining determinant, so -2, 3, 1, -1, and then change the sign. So it's a positive in one location, so I do a positive. If I do that, I end up with 2, -3, or -1. And then I want the cofactor 1, 2. So row 1, column 2, I want that one. Remove the row and the column it's in. Determine my remaining elements. Change the sign. Or adjust the sign as needed. For that number, it's a minus. So I have -1 minus 5, minus altogether, so I have +6. I lied. 4 times 1 is 4, so I have +5. There we go. And then C13, remove the row and column it's in, determinant of my remaining elements, adjust the sign as needed. So here I end up with 3 + 8, or 11. I did that one, and it didn't even matter what A11 was. Okay. Moving on to C. C says find a value for A11 so that the determinant of A is equal to 1. So there are many methods you can use to find the determinant of the matrix. You can use cofactor expansion along any row or column. You can use your modified fish method. But note, you already have the cofactors for row 1, so why not use row 1? So it's going to be A11 times its cofactor, which is -1, plus 5 times its cofactor, which is 5, plus -2 times its cofactor, which is 11. So cofactor expansion along row 1. Keep in mind, the sign adjustment has already been done. Oops. And then it says find a value for A11 so that the determinant is equal to 1. So I know that this determinant here, this determinant equation, should equal 1. And then I can just use it to solve for A11, and it turns out A11 ends up being 2. This is actually enough work. This shows that you know what you're doing. So that's enough work. Okay, so now you have a value for A11. And then it says, if the system is consistent, how many solutions for the system? So note, there's a couple methods we can use to figure out if the system is consistent or inconsistent and to figure out the number of solutions. The system is consistent if the rank of A equals the rank of AB. I don't really want to find the rank. The system will be consistent if the number of rows are, if all the rows are linearly independent. I do know that the determinant is not equal to 0, so that's one way I can figure out linear independence. So here, I'm going to use that one for my justification. The determinant of A is not equal to 0, therefore, it is a consistent system. And then the number of solutions. Turns out, as long as your determinant of A is not equal to 0, you also have a unique solution. Or one solution. So if you go back into the notes for week E, there's that nice chart. There's that summary information. And it tells you that if the determinant is not equal to 0, your rows are linearly independent, your columns are linearly independent, you have a unique solution, your system is consistent. There's a couple other things as well. Oh, the rank of A equals 3, or the rank of A equals the number of equations, the rank of AB equals the number of equations, all of that fun stuff. So just based off of this information alone, I know it's a consistent system and a unique solution. Okay, and then this one. Find the value of x1 using Cramer's method. X1 is going to be the determinant of A1 over the determinant of A. So I need to find, I already know the determinant of A, it's equal to 1. The determinant of A1 equals, what I'm going to do is I'm going to take column 1 and I'm going to replace it with B. So -5, 3, -2. And then the rest of A stays the same. Once again, it doesn't even matter what A11 is for this problem. So don't look at those variables and think, I have no idea what to do. What is A11? I don't know what to do if that's not a number. Just continue solving the way you would normally. Okay, if I do this, then I can use whatever method I want. I will use cofactor smash along column 3 for some odd reason. I don't know why. Negative plus negative. So -2 times, yeah, I'll do that. -2 times the determinant of these numbers. 9 minus 4. Minus 1 times the determinant of these numbers. -15 plus 10. And then plus -1 times the determinant of these numbers, which is 10 minus 15. I'll use I did modified fish in my prep. No, I did modified fish for my prep. So I really should. Otherwise, I'll probably do some math error. So modified fish, I just take my values and I copy them over. I'm not going to lie, modified fish was my favorite method until, I don't know, maybe this year. Okay, so these diagonals, I end up with -10. These diagonals, I end up with -10. These diagonals, I end up with -18. This way, I end up with -15. This way, I end up with -15. And then these last ones, I end up with -2 times -2 times -2, or -8. So it's going to be -10 minus 10 minus 18 minus -15 minus 15 minus 8. When I do that, I end up with -38 minus -38. So I end up with 0. My determinant equals 0. Which is fine. This isn't the determinant of A, this is the determinant of A1. So to get x1, I get 0 over 1, or which is valid, which is 0. So x1 equals 0. All of that work for a 0, but that's okay. I showed my work. So even though I ended up with 0 here, that's completely fine. I'm not finding the determinant of A, I'm finding the determinant of A1. So I just keep going, plug that into my equation, where x1 equals 0 over 1. So therefore x1 equals 0. There we go, there's problem 3. Once again, I can go to MATLAB, and I can check my answers. So I found A to be a value of 2, or A11 to be a value of 2. Doesn't matter what you call it in MATLAB. So I just called A. I plug in A, I plug in B. I can show that my determinant of A is equal to 1. I can show, so the reason why I'm showing, so there's no easy way to check your cofactors. However, we know that the inverse of A requires the adjoint matrix, which the adjoint matrix is filled with cofactors. So technically, if I take the inverse of A divided by the determinant of A, I get my matrix of cofactors. So this is how I can check my cofactors. And then I can also check to make sure that my x1 value is equal to 0. So here we go. So here's A, here's B, here's my determinant. It's equal to 1. Woohoo, means I did it right. Here's my matrix of cofactors. So cofactor 1, 1 should be 1, negative 1. Cofactor 1, 2 should be 5, and cofactor 1, 3 should be 11. Because my first column of my cofactors is my first row of cofactors of A. Or my first column in my adjoint matrix is my first row of cofactors in A. And then here's A left divide B. Notice that it's not quite 0, but it's practically 0. So I checked my work. I didn't try to use, I didn't type in my A matrix and say, okay, if I got a 2, what would I get for x1? Just follow the process. You're going to be graded on the process, so you need to make sure that you are doing your work on paper and you're not just typing everything into MATLAB if you get an answer. Once again, go all the way through and then go back and check your answers in MATLAB. I would hate for you to lose points because you sat there and you stared at MATLAB and you're like, wait a minute, that's not what I got on paper. Where is there a mistake? Because your mistake might be typing a number wrong in MATLAB. It might be a math error. And so you're sitting there and trying to figure it out. So make sure you go through all of the problems first and then go back and check your work on MATLAB if you have time. Okay, moving on to problem 4. We've got 10 minutes. Yeah, like I said, I will create videos doing the solution for the other problems if we don't get when we don't get through them, which is totally fine. Get through as many as I can. Okay, this is a fun one. Fun being it requires a little bit more thinking. So given the following system of equations, rewrite the matrix in rewrite the system in matrix format. Matrix format technically means AX equals B. And determine the following. So we want to find values for A33 and B33. That the rank of A and the rank of AB are equal to 2, and then the rank of A and AB are equal to 3, and that the rank of A is 2 and the rank of AB is 3. So essentially, the goal of this problem is to find the rank of A and the rank of AB. If you ever have to find the rank of A, just skip that and go to the rank of AB right away. Because to find the rank of A, it's the same process to find the rank of AB, you just have that extra column. But the answer will be the same. So first, write it in the system of AX equals B. To be honest, I'm going to skip over AX equals B and write my augmented matrix right away. So I do that and it ends up like this. 2, 3, 4, 12. 1, negative 2, 1, 3. 4, negative 1, A, 3, 3, and B, 3. Once again, those variables show up. Don't worry about it. This one is a little bit more complicated than the previous ones, but don't worry about it. Okay, I need to find the rank. So I'm just going to start with my row operations. I want my lower triangle of zeros. I'm going to just ignore A and B and just keep moving. So first thing I'm going to do is I'm going to say row 2 equals 2 times row 2 minus row 1. So if I do that, I end up with 2 minus 2, negative 4 minus 3. Um, 2 minus 4 and 6 minus 12. I like to write it out like that so that I can see, especially the signs. I don't want to mess up my signs. And then I'm going to say row 3 equals row 3 minus 2 times row 1. And I'm using row 1 for both of these so I can do them at the same time. If I used row 2 to make that a 0, then I couldn't technically do both of these at the same time. So keep that in mind. So I'm going to have 4 minus 4, negative 1 minus 6, A3, 3 minus 8, and then B3 minus 24. So once again, this is where these variables come in. If you don't know that number, that's fine. Just leave it alone. Just leave it as an equation. So when I enter it into my matrix here, I'm going to end up with 2, 3, 4, 12 for row 1. Row 2 becomes 0, -7, -2, and -6. And then row 3 is going to be 0, -7, a 3, 3, minus, minus, come on, 8. Why did I write down 6? Oh, duh, I'm looking at the wrong one. Minus 8, and then B3 minus 24. Okay, so I've got, it's a little more complicated. Those aren't just numbers, but still, I'm ignoring it right now. I'm ignoring it. I know I need to make this a 0. So I'm going to say row 2, 3 equals row 3 plus or minus row 2. When I do that, I get 0 minus 0, -7 minus -7. Now's where it gets a little more complicated, but it's not that bad. It's just a 3, 3 minus 8 minus -2. And then B3 minus 24 minus -6. So I get 2, 3, 4, 12, 0, -7, -2, -6. And then 0, 0, a 3, 3 minus 6, and B3 minus 18. Okay, I got it in REF. Here we go, I got my lower triangle zeros. Now I've got my rank. I just have these equations here instead. Okay, so now we go back up and we see that, okay, find values of A3, 3, and B3 such that the rank of A and the rank of AB are equal to 2. So if the rank of A, which is this side, and the rank of this is rank of AB. So if I want the rank of both of those to be 2, that means this needs to be 0 and this needs to be 0. So A3, 3 minus 6 equals 0, which means that A3, 3 needs to equal 6. And then same thing, B3 minus 18 equals 0, therefore B3 must be 18. So using my knowledge and saying, okay, if the rank is 2, that means I need an entire row of zeros on the A side. If the rank of AB is 2, I need an entire row of zeros all the way through. So therefore, A33 must be 6 and B3 must be 18. We will get to that. Okay, so there's that one. Identify the type of system. So if the rank of A equals the rank of AB, it's going to be consistent. The number of solutions in this instance is going to be infinite because the rank of A and AB is less than the number of equations. So you end up with that row of zeros, which means you get an infinite number of solutions. Okay, so then the second one says find the values of A3, 3, and B3 such that rank of A and rank of AB are equal to 3. So if they're equal to 3, that means this just needs to not be 0. So A3, 3 minus 6 is not 0. So you can make it equal to 1. It doesn't matter. It's just as long as it's not equal to 0. So you could say A3, 3 equals 7. That will work. And then it really doesn't matter on this side. B3 minus 18 equals, you could make it 0. It really doesn't matter. It can be anything. So I'll just make B3, 3 equal to 19. Just something that's not 18. Or really it could be 18. It doesn't really matter. So you need to recognize in what instance will you have the rank equal to 3? In what instance will you have it equal to 2? Make sure you label. So here's A, here's B. For C, or for this one, so if they're both equal to 3, it's going to be a consistent system and there is one unique solution. And then it says find values of A3, 3, and B3 such that the rank of A is 2 and the rank of AB is 3. So in this instance, if the rank of A is 2, that means that A3, 3 minus 6 equals 0, or A3, 3 equals 6. And then B 3 minus 18 has to not equal 0. So we can say B3 equals 19. Set it equal to whatever you want. Maybe you say it's equal to 1. It doesn't matter, just as long as it's not 0. So here's our 3 scenarios. In this scenario, we end up with zeros all the way along the bottom. In this scenario, we end up with something and something. In this scenario, we end up with zeros and then something. I chose this something to be 1 and 1, and this to be 1. It doesn't matter. Choose a number. If you just identify that A33 is any number but 6, that's fine. You can also say that B3 is equal to any number. But if you can't, like, hypothetically theorize for all situations, just pick one. Just pick one. It doesn't say a given numbers, it just says the rank. So if we have the ranks not equal to each other, then it's an inconsistent system and no solution, or a 0. And the last thing this question asks is to solve the system of equations for the first one. So we would end up with our matrix like this. I know we're out of time. For my first scenario, I end up with zeros all the way along the bottom. And then it's an infinite number of solutions. Just use Gauss-Jordan elimination in order to solve for it. So we can say row, I need to make this a 0. Get as many zeros as I can. Row 1 equals 3. Nope. 7, row 1, plus 3, row 2. If I do that, I end up with this. I divide this row by 14, divide this row by -7. I end up with this. You can write your system of equations. And note, with an infinite number of solutions, you're going to end up with your unknowns as functions of other unknowns. This equation tells me that x1 equals -11/7 x3 plus 33/7. This equation tells me that x2 equals -2/7 x3 plus 6/7. There we go. There's your solution. And then x3 equals x3. It's a free parameter. You can do whatever you want with it. Okay? Once again, if you want to check your answers in MATLAB, just plug in a value for A, value for 18, or for B. Plug in A, B, check RREF to make sure that you end up with that row of zeros. You can find the rank and the rank of A, B. So do it for all situations. So here is my first scenario where I end up with that row of zeros. Here's my second scenario where I end up with rank of 3 and rank of 3. And here's my third scenario where I end up with my rank of A on this side is 2, and my rank of AB, the whole thing, is 3. Okay, so we are definitely out of time. I will create videos for solving problem 5 and 6, which problem 5 is probably the longer, at least longer in terms of writing. And same thing with 6. But we are going to be done for today. That is our last lecture. So I will see you guys at the final. Make sure you go check that final exam folder. You'll see the practice problems. The solutions will be posted at midnight tonight, or tomorrow morning, I guess. And then make sure that you have the appropriate final exam link that indicates whether or not you're taking the normal exam for just the Zoom link, if you have extended time, or if you are taking the makeup. With that, good luck studying. I'll see you guys next Tuesday. I'm going to jump over to office hours.